Friends, welcome to the Python Development Workshop Day 4. I hope you people are good. Today is going to be the last session for the week, and today's session will be covering the object-oriented programming, and we'll see some of the exceptions that occur in Python, as well as see the file handling processes in Python. If I'm audible, can somebody please comment and say? Okay, if I'm audible, then we can start. Okay, so if I see the very first thing that is the topic for the day, that is classes and objects in Python. So, what is object-oriented programming? Object-oriented programming is basically a programming paradigm or a process of doing programming which is based on the objects, which is based on the creation of the objects and the classes. Also, object is an instance of class. That means your class is a that means your class will have certain attributes and functions that are going to define the objects. Every time you create one object for the class, it is going to inherit those functions and those attributes of that class. Now, what does the object-oriented programming does? It encourages the code reuse and modularity. It encourages the code reuse and modularity. That means for defining certain type of an object or a thing, you do not have to write the code again and again. The key principle on which the object-oriented programming is based is the encapsulation, abstraction, inheritance, and polymorphism. These are the four basic key principles of the object-oriented programming. Now, let's see onto the fact what is a class. So, class is a blueprint for creating the objects. For creating the objects, that means of how you can define each of the functions and attributes that are common to our objects like can be put together to perform the task. Okay, I'm sorry, I think I did not present my screen. Okay. Hmm. Okay. So if I say go on to object-oriented programming, object-oriented programming is a programming paradigm that is based on classes and the objects. Object is an instance of class, whereas your classes it comprises of the attributes and the functions that are common to the all objects. Now, the object-oriented programming encourages the code reuse and modularity. Code reuse means that you can use the same object and the classes or same class that you have created for a particular case for different objects that have the same attributes and the functions. The four basic key principles on which the object-oriented programming is based is encapsulation, abstraction, inheritance, and polymorphism. We'll see each of them in detail in the following upcoming slides. These are the four basic key principles on which the object-oriented programming is based upon. Now, if I say what is a class, so a class is a blueprint for creating the object. Blueprint for creating the object, that means you will have similar type of attributes and the functions or the methods defined, and you can inherit them from the class which you define using the class one. Whenever you want to define or you want that particular class is going to be created, you are going to use the class keyword. It contains the various attributes and the methods. Various attributes means those are the variables. The variables inside a class are known as attributes. The attributes can be local attributes or global attributes. Whereas the methods are the functions inside a class. Suppose that if I say I have a class named car. If in this example, if I say this, I have a class named car. Here, def init is a initial function because def is going to tell you that this is a function. But init is a default function that has called the parameter brand and model. Now self.brand is equals to brand. That means it is going to point out the brand variable to a brand parameter that is going to pass inside this car. Is it clear till here? Voice is not clear. Is my voice clear to everyone? Is my voice clear? Okay, at any point if you find that my voice is not clear or the screen is not visible, please try to comment so that at that point only the problem is resolved. Otherwise, I carry forward the things and it goes to a longer end. Okay, if it is clear till here, can I proceed? Ready to understand the basic principles of the object-oriented programming, what is a class. If it is clear, then we can move forward. If it is clear, then we can move forward, I guess. Okay, I guess it is clear, so we can move forward. Okay, now we'll see what is an object. An object is an instance of a class. An instance of a class means that is a one copy of the class. A blueprint, which copy that represents the blueprint of the class. Okay, and objects have variables, that means attributes and the methods. Now let us see an example of an object here. For the web class that we have created class car. Okay. Now let's see. I have an example here. I will create an object with the name my car and it's going to have the car physical class there. But these are the parameters that are required to take when creating the object for the class. Suppose here I wanted the brand name and model. So I have to specifically like say here what are the brand and the model for the particular car. So that this object is like taken forward in a precise way. Now if I want to print the variables or print any of the output from the function, I have to say object name dot function or the attribute. So here I have the attribute. Suppose I want to take a look at the brand. What is the brand of that particular car? I will simply write class dot attribute and that is my car dot brand. So similarly, if I ask for if I want to write the model, what should be the syntax here? Can somebody ask me? I'm saying if I want to print if I want to print the model of the same object, my car, what should be the statement here? Can somebody tell? Can somebody please tell what should be the statement there inside the prompt? I'm saying if I want to print the similar case for the model, if I want to print the model of the particular object, my car, what should be the syntax? Okay, since no one of you is answering, so I'll myself type this. You have to write my car dot model to print the output for the model case. Okay, now we have seen in the class that we have some init function. This is the init function. This is initial function which is also automatically called when the object will be created. Okay, so it does not matter whether you create the init function explicitly or not. Whenever your object will be created, this is going to be called out. Now let us see an example. Now let us see an example here. I have a class named person. Okay. And this class named person has got a init function. This I told you this init function is explicitly called or not. It is going to be automatically coming in the case whenever object will be created. It has got the two parameters, name and age. This name parameter and each parameters are going to be like redirected to a memory location using the self parameter here. We'll understand the self parameter again in the coming slides, but this is how like you direct or redirect the memory location to that same parameter that is being like given into the object or the whenever you create a new object with that particular parameters. Okay. Any doubt below? Say object-oriented programming is not as easy as the structured programming, and when you come on to the high-level programming languages such as your C++, your Java, these are the programming languages that takes a lot of efforts and are basically more dependent on the object-oriented classes and objects. Hence, it is always easier to understand things from the basic. That is why I'm telling each and everything from the basic. See, if I ask you here, what is the use of the function? The same function is basically a function that is automatically called whenever the unknown object is created. Also, it does not depend whether you explicitly call it or not. It is already called. Now, if you have any doubt here, you can ask. Okay, if you have no doubt, then we can move ahead, I guess. Now we will ask see what is the basic difference between a class attributes and instance attributes. So a class attribute is an attribute that is shared across all instances. That is shared across all instances. That means All the items that are given to a particular class is going to be inherited by all the objects, and the additional attributes that are given only to a particular object will not be shared across all the objects that will be made under that class. Now, let's see upon the example. Okay. Okay, if I see here, I have created a class named dog. Okay, here class dog has a called an attribute that is a species that has the value canine here. Okay, and have we have the init function here. We have explicitly called this function here, and we have a parameter or the one more attribute that is name. Now this name attribute will be changing as per the new object will be created. This species with canine is going to have the same parameter. It's going to have the same value for that species, that is canine. So this is going to remain intact with all the objects that we create under the same class, and hence this is a class attribute. Now if I come to the fact of name, this name is going to change every time a new object is going to create. So here this is an instance attribute. Instance attribute that it is dependent on the every object that is created, and hence changing its value as all as whenever the new object is created. Now we have methods in class. Till here it is clear. If it is clear, then let me know. If it is okay, then we can proceed. Okay, I can move forward. It's okay. Now if I see methods in class, methods in class is a function inside a class. And method basically known the functions that are there inside a class. The first parameter that is there inside a class, an instance method is the set. This one. Okay. So this is the first parameter that is already that is there in the init function. Now, if I see inheritance, the inheritance allows class to derive the properties from another class. This reduces the redundancy and the promote code reuse. That means inheritance is a basic property in Python that is reduce the redundancy by inheriting the properties from the parent class. And this basically promotes the usage of code that is already written. Now, if I have an example here, I have a class parent here. Okay, and this class parent has a function show. This is called this parameter in which is and it has a statement under it. This is a parent class. This is a parent class that means this is something that shows that that was inside a parent class. Now, this is one of the basic rules of the object-oriented program. Now, second one is polymorphism in Python. So, the polymorphism allows the same function to work in different ways. That means, if you want a particular function with the same name to work in different ways or to have outputs in different ways, you can use polymorphism. So we can have different classes that can have methods with the same name, but we have different implementation. Suppose we have two classes, class one and class two. They have got the functions of function one and function two. But since they are got into different classes, they have got different implementation. So this phenomenon is known as polymorphism. Now, if I say example, okay, so the class cat functions is going to become a sound of a cat, class dog. So all the function is it is going to return the same message again. It is going to return the sound of dog. So this is how you can basically use the polymorphism in Python. Now we have encapsulation. So, encapsulation restricts direct access to the object. Is it clear in polymorphism? Okay, since you're talking about then we can proceed, I guess. So that's the encapsulation in Python. Encapsulation in Python basically refers to the like restricting the direct access to the object data. Use underscore to indicate the private variables. Okay. So there is several information that is not relevant to the human life. So the process of hiding those information and just displaying the required information to the user is known as encapsulation. So there are different types of variables in Python under the object-oriented programming. The one is the private variable, the one is public, and the other one is protected. So it is always essential to declare a type of variable for its more usage and restrictions on it. So it's just saying here that whenever you want to have a private variable, you should use underscore. So one underscore is for the protected, no underscore is for the public, and two underscore is for the private variables. Now I have a class bank account, let's say, and this has got the init function and has got the parameter balance or the attribute as balance. Here self dot double underscore balance is saying that this is a private variable. If I just have this single underscore here, that means we just have got the protected number. That means balance is the protected variable or the attribute. Now we have the abstract classes and the interfaces. So, so the abstract classes cannot be instantiated. That means you cannot initialize the abstract classes. There are several classes in which you can initialize the things, but only abstract classes you cannot initialize the things. Hence, abstract classes are used as a blueprint for the other classes. Okay. They are as some particular class for the other classes. Whenever you want to create an abstract classes, you should have the ABC module imported. So let us see an example from ABC import ABC. That means you are going to import the ABC model here, and it's imported in the way ABC. Now here we have a class named animal. It has ABC, that means this is a abstract module for the class. Now at that abstract method is going to say that this is an abstract method and there can be no initial animation for that particular class and methods. Okay, is it clear till here? Okay, since you have no doubts, then we can proceed further. Okay, so if we see the summary of this object-oriented programming, we see that the classes defines the blueprint for the objects. Defines the blueprint for the objects, that means it is going to give you the several attributes and the methods for that particular for the objects that are going to remain common to all the objects. And objects is the instance of the class that inherits the methods and the attributes from the class. Now we have several basic principles on which the object-oriented programming is based on. Number one is encapsulation, the second one is abstraction, the third one is inheritance, and the fourth one is polymorphism. Encapsulation is the that is keeping the encapsulating the relevant information and then keeping back the irrelevant information of the user. Abstraction is the hiding of the various complex implementation of the things from the user. Inheritance is how a one class can inherit the properties, methods, and attributes from the parent class. Polymorphism is basically how two classes can have this function of the same name and different implementation. Now, we thought that object-oriented programming is helpful in structuring the code efficiently and reusing the components. Whenever you create something like code or like in programming, you should always have one thing in mind that it should be efficient from the time purpose also for memory purpose also. Okay. Now, one thing that you can do to make it efficient is whatever you have written down in the previous course, you are trying to reuse it. This is a basic idea of how you can implement the efficiency inside your code. Do you have any doubt till here? This is was all about the object-oriented programming. We will go back now. We will see the and I will see the like practical implementation to it. But before that, do you have any doubt? So if you have no doubt, then there is probably a question to let me see whether you have understood or not. Is how you can like define a class or something like asking the complicated question, but I'll ask you a simple question. Like, how do you differentiate between an instance classroom or a class activity? Can somebody in the comment section please reply? Okay, I'm asking you if I want to create a class. Okay, do you, can somebody tell me the difference between an instance attribute and the class attribute? So basically, how you can differentiate between them? Okay, so I'll proceed with the practical part. If you have any doubt, you can ask in the comment section. Okay, let's see here. A class in Python is a vector. Okay, a class in Python is a user-defined template for creating the objects. It bundles the data and functions together, making it easier to manage and use them. When we create a new class, we define a type of an object. And we can create multiple classes classes for the particular, and we can create multiple objects for the particular class. Now, the classes are created using the class keyword, and the attributes are variables defined inside the class represent the properties of that particular class. And the attributes or the functions can be accessed using the block operator. Now, if I see here, okay, to create a class. Now, this is way how you have created a class named dog. Now, we have to create an object. So, object is an instance of a class and represents a specific implementation of the class. Now, if I see here, okay, so this way you have created the object. Now, you have to call the attributes print open dot sound. Okay, okay, I've not run this side. Okay, so this way we have told you a simplest way of how to create a class and how to create the object of that particular class, and then how we can call the attributes. Now we'll see the use of init function. In Python we almost have the init function that automatically initializes the object attributes when an object is created. Now, let's just see the use of okay, now I have a function there. Self parameter and we have a name and HOD. Okay, so if I associate doesn't. Okay, so if I try to explain you this piece of code, here class dog is a class which has the name dog. The init method will initialize the name and the age attributes and have a new object, and whenever a new object is created, it is going to initialize and automatically will be called. No. You can see how you can initiate the object with a function. Okay, I'll just copy this from here tab. This is basically the object created. Okay. Okay. We just have this both of them separate. Now let's see here how you can call the attributes here. Okay, I'll just enter this. Okay. So this way you can see how the init function works to call the attributes and make them assigned to that particular class. So that the various methods that we have listed are now displayed as per the results. Similarly, you can have the other one also. Okay, now I print here. Okay, so this is way how you can create an object with the init function and how you can how to create a class with the init function and how you can create the object for that and how you can call the attributes. Do you have any doubt till here? Now we'll see the class variable and instance variable. Self. Okay, we just do the name and each parameter. Self dot name equals to name. Self dot age equals to age. We just have the class created. So okay, the species is same for both the dogs, dog and dog. Now we'll see for the name. Okay. So the species is set. The name and age of the dog is changed as soon as the object is changed. So the here see we have two classes. We have two type of attributes. A species attribute that is a class attributes and the name and the age attributes that are the instance attributes. So class variable. These are the variables that are shared across all the instances of a class. It is defined at the class level outside any method. All objects of the class share the same value for a class variable unless explicitly called over. If I talk about the instance variable here, these are the variables that are unique to each instances. Okay, that are unique to each instances and change the value as per the object attributes or the parameters that are given. So, instance variable are defined within the init function with instance methods. If I see this code, we have a class variable that is a species here, which is shared by all the instances of the class. And here we have the class species, that is the class variable. Class variables can be accessed by the class name dot class variable. The instance variable refers to the object name. Okay. Any doubt here? Okay, if you have not heard, then we can I think proceed further. Okay. Now I will see the encapsulation. So in Python, the encapsulation refers to the burdening of data and methods that operate on the data as a single unit. Typically, how a class like defines. Here, what does the class do? Class binds your attributes and a function into a single unit of that particular class, and the object can use it. This is what an encapsulation means. Encapsulation process of hiding the internal state of an object and recording all the necessary information to the user. What does the encapsulation do? Encapsulation provides better control over the data, prevents the accidental modification of data, and promotes the modular programming. Okay. Now, if I say Python achieves the encapsulation through public, protected, and private attributes. That means how you want your or how much reach you want of a variable, of a particular variable to be there, it depends on that. Now, how does the encapsulation works? The variables are kept private or protected, meaning that they are given several reach to which they can be operated and can be used. Instead, that now accessed through methods. Methods act as an interface through which the external code interact. For instance, getters or setters functions are used to retrieve and update the value. Now, if I see the encapsulation, the variables that are allowed for manipulation can be manipulated by the same intact. Now, we will see the public members, private members, and the protected members in detail. Okay. Okay, so if I see the public member here, I have a class name, public. Okay. Now the inner function. Okay. Well, we now don't need this class. Let's show this. Okay. And we have an object here for the public class. Okay. Yes, I have. John and age is 23. This is the subject dot. Simply say print. Okay. Okay, so this way you can see that your class public has given you the age and the name. If I try to understand this code, we'll see that the public attribute that is name, this attribute is declared without any underscore prefixes. It is accessible from everywhere and both inside and outside the class. Now we have a public method that is basically an init function over here, which is accessible from any part of the code and is basically telling you that this is the name of the class, this is the name of that particular object, and this is each of that particular object. For obj is an object or an instance of public class, and it displays the method call, and it basically gives you the John, like the name and the age of that parameter, like of that object. So the init method is basically a constructor and runs as soon as the object of the class is created, which is similarly safe for the class protected. Okay, okay. I just place this remove this. I just and rename this as protected. Where is it? Is this? Okay. So this is basically the protected members. The protected members are identified with a single underscore. Okay. And this attribute is prefixed with a single underscore, which will suggest that it should be treated as a protected member. It is not enforced by Python, but it indicates that it should not be accessible outside of the subclass. Always remember the subclass inherits the protected members, but the private members are not inherited by the subclass. Now we have the private members. Okay, I will just have the double underscore. It states that this is going to be private member. Okay, just remove these two lines. Now, this is a private class here. What is SC to the fourth encrypted? That the private members are identified with double underscore. There is a double underscore before the class name. Okay, so if I see here this code, I'll see that the private attributes are prefixed with a double underscore. This double underscore says that these type of members will not be accessible outside this class. That means the subclass also cannot inherit these members. Now, if I see the private attribute, name and age. These attributes are prefixed with two underscore, which makes Python enforce privacy by name, managing their reach and other things. If you are unable to try to access these private members directly, it will this will like this will say this will like okay, so this will reinforce the encapsulate of the Python. Any doubt till here, students? If you have any doubt, you can ask right now. guys are not asking any question currently, so I will just give you one exercise to practice, and I will see that. So, that is to create just this Python program using loops. Now I'll ask you to create a Python program that basically uses the object-oriented programming. Just wait for a minute, students. Okay, so I'll give you a question. You just have to practice that. Okay. Okay. Groups, concepts, concepts, simulate, simulate a simple school management system. Just okay. So I'll just give you the details that I want inside this. Is that you have to create a person class. You have to create one class that has not got name person. That is going to have the attributes name, age, and a method display to display the properties, that is the name and the age. Second, you're going to have the create a student class that is going to have the additional ideas of the person, student ID. You're going to override this display function to represent that. Now you have the teacher class. This teacher class is going to have the additional attribute that is subject for which he or she will be teaching, and is going to override the display function to display that. Now in the main block, we are going to create one student and that one teacher object that will call that display methods. Okay. Now you're please requested to please do this exercise. Okay. You got the question? What I asked you to create? If it is clear, then we can move ahead with the exceptional handling. If you have any doubt, you can ask. We should move ahead with the exception handling. Please help me. Okay, so if there is no doubt, then we can probably proceed. We'll move on to the exception handling now. Okay, so what is exception handling? The exception handling is a mechanism to handle the runtime errors. The runtime errors are errors that we encounter when we run our program. So in the first session, I've already told you that there are various errors that we encounter when we run the program. So the exception handling prevents the program from crashing. It ensures that the smooth execution of the code. It ensures that the code is run without any error. And for doing that, you can probably use the try, except, value, and this like keywords to use the exception handling. Now, we have common type of exceptions in Python. So, very frequently encountered ones are divisions and zero division. Whenever you try to divide any number adding value with zero, it's going to result you into the exception, that is zero division. Type error is when you want when you have invalid data type conversion. Then we have the name error, when you use an undefined variable. We have an index error, accessing an invalid index inside a list, tuple, or anything is going to give you the index error. Now we have the key error. Key error is whenever you want to have, like this basically occurs in the dictionary. Whenever you want to access a key that is not present inside the dictionary, is going to result into a key error. Now we have the value error. Value error is an invalid argument for a function. And what is an invalid argument for a function? That means that particular like value or the variable is not there. Now, any doubt till here? If you got no error, then we can proceed with the payment. Okay, then we can proceed ahead. Okay, So we have a basic try and accept block here. The try except blocks will handle the exceptions gracefully. For example, if I have a try block here, I have an expression that is going to give a try block. The try block is also going to contain the error. We have x is equal to 10 now we have a zero division. This except block is going to give the solution to that particular error that we have inside the try. Now we have an except zero division. What is the name we are giving to the error? This is going to print that we cannot divide by zero. Now, how you can handle the multiple exceptions? You can use the catch block to handle the maximum multiple exceptions on a single block. For example, I have a target ABC and F. This is an invalidated or conversion. Okay, I have a block which is going to carry whether it's a value error or whether it is a type error. So both of these errors you have to print that is an invalid input. Now, how you can use the else clause. The else block executes if no exception occurs. That means when you have something exception in your driver, and then you execute the exception block. If there is no else block, like if there is no exception in the driver, then this else block will be executed. Now we have the finally block. This finally block always executes whether there is an exception or not. And it's basically used for the cleaning of the operation. That means the all the multiplications that we have allocated are erased. For example, we have the try block. Here this try block is going to have the error that is going to open this file data.txt. There can be an error that this file is not existing inside the system. So we have an exception file not found error. That is going to print that particular file is not found. Now this finally block will be executed once all of these operations will be done. It's going to clean up the memory. Now, to any doubt here, okay, if you have any doubt, you can ask. I could only say this. Since you don't ask, I cannot. I don't know whether you have any problem or not. I just assume that you don't have. Okay. Whenever there are any exceptions, then you want different from the customer. You want to design those exceptions then. So here we use a ways to generate the exceptions manually. For example, if I check we have a definition here, check age, it is going to have the parameter age. Okay. Whenever your age is less than 18, it is going to raise a value error that your age must be at least 18. Or else it will become that your access is not granted. Okay. Now, this is how you can manually erase the error using a raise bar. Okay. Now we have to define the custom exception classes. You can create a custom exception by inheriting from the exception class. That means, for example, here, if I say that You have a class custom. Okay. Here we have an exception. Now here we have the init function, which is or the active test message. This message is an instance activity. Okay. So this is how you can define a custom exception for the classes. Now, the best practices for exception handling is like how you can handle any which are not necessary exceptions. I mean that exceptions that are not relevant, you should not handle them. Okay. Choose a specific exception type instead of general exception. And that means you should try to handle the exceptions with a particular, like the very specific exception rather than like rather than like circulating them or clubbing them into a single generic function. Keep error messages as informative as the process. This basically uses keep error messages as informative as we can, since this helps in resolving the error as soon as possible. Now, log exceptions for debugging purposes. You can use the log exceptions for the debugging processes. Now, avoid using the class block and except class. That means you should avoid using the class statement inside the except block for easier and uh, efficient handling of the exceptions. Now, okay, so we have a summary of exception handling here, which says that exceptions help in error handling and program stability. That means you can handle the exceptions for error handling and the program stability. We can use the try, the catch block to catch the errors. Now we can have the else block, which means always when no exception occurs. Finally, block will always execute whether there is an exception or not. You can use the custom exceptions to create for the specific needs. Any doubt below? If you have any doubt, you can ask me to explain about it. Okay. So whenever this errors in Python, you can do two types. You can have the syntax errors and you can have the exceptions. The errors are the problems in a program in which the program method stop the execution. On the other hand, exceptions are raised when some internal events occur which change the normal flow of the program. Now we have the different type of exceptions in Python. In Python, there are several built-in exceptions that can be raised when an error occurs during the exception of a program. Here are some of the basic types of exceptions in Python. We have the syntax error. This exception is raised when the interpreter encounters a syntax error in the code, such as the misspelled keywords, a missing code error, and indentation error. Now we have a type error. This type of error or exception is raised when an operation or the function is applied to an object of the wrong type, such as here. adding a string to an integer or anything XYZ types. Get the name error then this exception is released when a variable or a function name is not defined in the current scope. The index error occurs when an index is out of a range. The key error when you try to access the key that is not present inside the dictionary. Then the value this exception is released when a function or method is called with an invalid argument or input type. Then we have the attribute error. This exception is released when an attribute or method is not found in an object. We have a zero division error when you try to divide a value with zero. And the import error when you try to import a wrong module. Then let's see each of these errors in detail. Now let's say I have Excel equal to 5. I'll just say it. And Excel. So this will say that there's an indentation error. You should have an index. You should have an indent after the if statement. So this is the syntax error. Now, suppose I am marks student, let's say 63. Let's just say don't. So this is gives you a zero division error. Now, if I say type error, that's an example of type error. Suppose I have this is equal to 5 and I want to make first. And I'll just ask like this gives your type error. Now we'll see how you can use the try and example to use it. I'll just say accept. I'll just run this. So this does not now begin anywhere. It seems that x and y must be of the same type. So the try and the except statements are the catching expressions. Try and except statements are used to catch and handle the exceptions in Python. Statements that can raise the exceptions are wrapped inside the try and the statements that will handle the exceptions are written inside the except block. Any doubt till here? Okay, we'll move ahead then. Okay, so I'll just create one list here. A equals to have the elements 1, 2, and 3. Okay. I got the job. Then A3. Okay, I'll just say this. So it's saying that an error occurred for this A3 since there is no element with index 3. Now, we'll see the else block. Okay, so that's all about this code. I'll just leave this one. Okay, an error occurred. Now if I write like this, no error occurred. That means the else block will only be able to work if there is no exception in the try block. If there are exceptions in the try block, then we are not going to have the what is we are not going to have the else block execute. Now we see the family keyword. So Python provides a keyword family which is always executed after the try and exit blocks. The final block always executes after the normal termination of the try block or after the try block terminates due to some exceptions. Okay, let's see this code. Running try block here. Okay, we have a let's see, we have an okay, now just have a family block as well. And yes, okay, and yes, see, shifted. Listen. So, suppose if I divided this with 2. So, where there is an exception, it is still it's executing, if there is no error, still it is executing. Now, so the risk statement allows you to allow the programmer to force a specific exception to occur. The sole argument in this indicates that the exception to be raised. This must be either an exception instance or an exception class. Okay. Now we see the basic advantages and disadvantages of exception. So, advantages of exception handling are that it improves your code reliability by handling the exception properly, preventing your program from crashing or producing the incorrect results due to unexpected errors or input. Also, it simplifies error handling by Exception handling allows you to separate the error handling code from the main program logic, making it easier to read and maintain your code. The cleaner code will know with exception handling you can avoid using the complex conventional statements to check for errors. Okay, we have easier debugging when an exception is raised. The Python interpreter prints a traceback that shows that the exact location where the exception occurred, making it easier for the programmer to debug the code. Now we have disadvantages of exception handling. The exception handling can be slower than using the conditional statements to check for the errors, as the interpreter has to perform additional work to catch and handle the exceptions. Now we have exception handlings can make your code more complex, especially if you have to handle the multiple types of exceptions or implement the complex handling logic. Improperly handled expressions can potentially reveal the sensitive information for the programmer, creating the securities vulnerabilities in the code. So it is important to handle the exceptions carefully and avoid exposing too much information about your code to the user. This was about the like file exception handling. Now we see the file handling. Is any doubt till here? Okay, so let's see file handling. File handling allows the Python programmers to read, write, and manipulate the files. Okay, so basically they are used for storing and retrieving the data. You can support different types of files, like you can have the text files also, binary files, CSV files, etc. to store and retrieve the data. You can use the open function to interact with the files file. Open function to open the files file. Now, how you can open a file? The basic syntax to open a file is with the filing and the mode. Whether you want to write a file, whether you want to just read the file, or whether you want to make some changes in the file. This binary mode will open both read and write modes. Okay. Now we have the R for read mode, W for write mode, S mode, and A for append mode. So now you can write as per your usage. Now, if I see how you can read from a file. So the methods for reading from file are read. This will read the entire content. Read line is going to read one line at a time. Read lines will read all the lines and will convert it into a list format. For example, if I see here, I have a file that I'm going to open. This file is going to have all the contents from this data file in the read format. And if I write file.read, it is going to read the entire content of the file and is going to be seen in the content version. Okay. Now if I want to see the contents, I just print that. Now we'll see how you can write it. You can use the W mode to write a new content. That means whenever you want to write to a content, you use it in W mode. You can also use A mode whenever you want to add something to the existing file. Now here we have to open the file with open function and we have to write, so we simply write file the content that you want to write and which is file.close. File.close is necessary to close the files to free up all the memory allocations. Now we see the with statement. The with statement automatically closes the file. We do not need to write the file. Dot close function. For example, if I write with open this is going to like directly close the file. You do not have to write the file dot close function. Now, how we'll see how you can work with the binary files. Binary files store the data as the raw bytes. That means you can use read binary or write binary codes to work with the binary files. For example, if I write with openimage.jpg IPS file, this is database file. It is going to read all the image. That's going to read the content inside the image.jpg file. Now, if I want to write, this is going to write the file. Now, these are the various methods in Python. File.readline is going to read the n characters. File.readline is going to read everything. File.readlines is going to read all lines into the list. File.write text is going to write that particular text into the file. File.seek offset is going to move the cursor to a specific position. Okay. File.tell is going to return the current position of the cursor. Now we'll see how you can delete a file. You can simply use the OS models to delete the files. Example, you have to just import the OS model. You just have to write os.remove function with the file as the parameter to be removed. Now you can how you can handle the file exceptions. Always handle file exceptions when working with the files. For example, there are very famous another concept that the file not existing inside the system. So with that, what you can use, you can simply write with open this as file. And you can see that that particular file is not existing inside the system. In the try log, you just have to open the file, you have to read that file, and in the except log, you can have the exception raise. Now, what is the summary of Python? Python allow you reading and writing the files easily. Whenever you want to read and write the files, Python admin is the best option. You can use the option open the file and you can use the read files, write files and append files. Always close the file with the with statements to free up the memory allocations to that particular file. Handle file related errors successfully. You can add the file, you can have other tasks done in the driver, and then you can have the exceptions done in the Excel. This was all about the file handling. If you have any doubt, you can ask. Also, if I ask you one question related to file handling, that is, which statement is used to close the file except the file.close option? Can somebody please answer this? Also, please do not forget to do that task that I'm giving you today. Okay, since you have not asked me, this was all about today's session. For any doubts, anything, you can easily contact me. See you soon.